welcome to our very first lesson of calculus. Now, to get started, we need to familiarize ourselves with two terms. One of the terms is rationalizing. Now, when we are talking about rationalizing, what we are looking for is how do we get rid of that root in the denominator? Now, going back to functions as well as advanced functions, we learned that we don't like roots in the denominator. So that's our first topic at hand. And then our second topic at hand is conjugates. Now, for conjugates, we're looking for another binomial term which has the opposite arithmetic operation as our first binomial term. So let it be something like a plus b. The conjugate of a plus b would then be a minus b. One quick way to remember this particular idea is applying the difference of squares. Let's say we had 1 over root x. What we would do is multiply
root x by both, yeah.
So both the numerator and denominator. And this will leave us at root x over x. Okay?
Okay.
If we had, let me write down an example.
I'm just gonna go get my notebook
Okay.
so I can write this down as well.
Yes.
Back. Hello?
Yeah.
Yeah, I'm back.
Okay. So this is one example of rationalizing. Another example of rationalizing, which is a little bit harder, is if we have something like root x plus 1.
Uh-huh.
Do you know how to go about it?
You would multiply root x plus 1 on both denominator and numerator?
No. So over here, we have to use the difference of squares because if we multiplied it with both the numerator and denominator, I'll show you what happens. I'll do it the way you're saying. This will become root x plus 1. This becomes root x plus 1 square, which then becomes x plus 2 root x plus 1. So as you see, the root is still in the denominator, right?
Uh-huh. Okay.
So do you remember the difference of squares?
Not really.
So the difference of squares is a plus b times a minus b, which is equal to
A squared. Is it a squared plus or minus b squared?
no, it's just a square minus b square. So this over here is your difference of squares. Okay.
Okay.
So based on that, I'm going to multiply this by root x minus 1, this as well. And now I have root x minus 1 over root x squared minus 1 squared.
Could you scroll up? I just need to write it down. The previous examples, yeah.
Good?
Not yet. I'm almost done.
Okay.
Okay, I'm done.
All right. What about if we had 2 root x over 3 minus root x? How would we go about this one?
2 root x over 3 minus root x. So I'm guessing you'd multiply it by 3 plus root x.
Yeah. So multiply both the numerator and denominator by 3 plus root x. And we get 2 root x times 3 plus root x over 3 squared minus root x squared. What would this equal to?
Let me just write this down.
We're not done, by the way.
3x squared. It would be I'm not really sure.
Okay. So we need to apply distributive property. So we multiply this thing with this one and this one. So then we have 2 times 3 and then root x. And after we have 2 root x times root x over 9 minus x. Are you able to figure out what this will result to?
That'd be 6 root x, 2 root x squared. 6 root x plus 2 root x squared.
Which is? Okay, we could do an extra step.
Would that just be 8 root x cubed?
Nope, not 8. So they're not like terms, and I'll explain why. Because this over here, the exponent is 1. However, this one over here, the exponent is 2. So if we were to look at it, this is a, this is a square. And because they're not like terms, we cannot add them.
Okay.
So go back to what happened over here. So what happened to this root x squared?
It just turn into x.
Okay, and do you understand that or no?
Yeah, because you're multiplying it by each other.
Mhm. So now this will become 6 root x plus 2x over 9 minus x. And that would
So,
be your final answer.
okay, let me just write this down.
A plus b, okay? The conjugate of this would then be,
A is that a is that
sorry,
a
plus,
plus a minus b?
yeah? Let's do a few more examples over here. If I had 2x minus 7, the conjugate of this will be,
2x plus 7.
yeah? If I had root x plus 3x squared, the conjugate of this would be,
Root x minus 3x squared.
yeah? If, are you ready for something a little harder or you want to still build up?
Mhm.
Say that again.
Okay.
Let's say root 20 plus 3x cubed, the conjugate of this.
Maybe root 20 minus 3x cubed.
Yeah. What about if I had root x plus 1 minus 7?
Root x plus 1 plus 7.
Yeah. What about if I had x plus 2y minus 8?
X plus 2y plus 8.
Yeah. Any question with this?
No.
Okay. So you understand what rationalizing is?
Yeah.
You understand what it means by getting the conjugate of something?
Uh-huh.
Okay.